Complex fractions have two rules. Basically, what you want to do is find the common denominator of the denominators and then after you do that, multiply through by that common denominator. And then once you multiply through by the common denominator, then you want to cancel as much as possible. So let's look at number 7. The common denominator of the denominators is going to be 4. So all I have to do is multiply everything by 4. 1 times 4 is 4. 1/2 times 4 is 2. 2 times 4 is 8. 1/4 times 4 is 1. So then what happens when I do that is if I multiply everything by 4, notice that I'm multiplying the top by 4 and the bottom by 4. That's really multiplying by a foo, because 4 over 4 is equal to 1. So as I do that, I get my final answer. The common denominator in problem 8 is x. So I'm going to multiply everything by x. 2 times x is 2x. 2 over x times x is just 2. And then as I do this in the denominator, I get 2x plus 2. Now, I can factor out a 2 from both the numerator and denominator. So those cancel, and I end up with x minus 1 over x plus 1. So I have to cancel things out that I possibly can. Number 9. So if I look at the common denominator of the denominators, just if I look at this part of the problem right now, that's a 2. So I'm going to multiply the numerator by 2. Then I'm going to multiply the denominator by 2. And so I end up with y minus 2y over 2y plus 1. And now I end up with a problem like the front side of the paper. So I'm going to multiply this y by 2y plus 1 over 2y plus 1. So I get 2y squared plus y over 2y plus 1 minus 2y over 2y plus 1. And then I can simplify this to 2y squared minus 2y plus y gives me minus y over 2y plus 1. And I could factor the numerator, but it wouldn't end up giving me anything that I could cancel with the denominator. Number 10. So if I look at the numerator, x squared times x plus h squared is my common denominator of the denominators. So I'm going to multiply the top and bottom by x squared times x plus h squared. And what ends up happening is I get x squared times x plus h squared. The x plus h squareds are going to cancel from this part, and I'll end up with just x squared. From this part, the x squared times x plus h squared, the x squareds are going to cancel. So I end up with x plus h squared over here. And then the denominator, the total bottom denominator, ends up being x squared times x plus h squared times h. Now, what I can do is I can distribute the numerator, because I might end up being able to cancel something. So if I distribute the numerator, I get x squared minus x squared minus 2xh minus h squared. I'm going to move all of these things down a little bit. And then the denominator ends up being x squared times x plus h squared times h. Notice that the x squareds end up canceling here. Then I can factor out an h from the numerator. So I have negative 2x minus h. And then the denominator is h times x squared times x plus h squared. The h's end up canceling. So I end up with negative 2x minus h over x squared times x plus h squared. That's my final answer for number 8. Number 9, my common denominator is 3x times x plus 2. So I'm basically playing what's missing again. So I multiply this one by that, or this one, and I get x plus 2. I multiply this term by that, and I have 4 times 3x. The denominator, this part is missing a 3x, so I get 3x squared. Then when I look at this part is missing a 3 and an x plus 2. So now I simplify everything, and the numerator ends up being negative 11x plus 2, and the denominator ends up being 3x squared plus 3x plus 6. Number 12. If I look at the denominator of the denominators, it ends up being 2n. So I'm going, or I'm sorry, it ends up being 2n. So I'm going to end up multiplying everything here by 2n. And actually, in this case, I'm going to have to multiply everything by 2n over 2n because there are fractions in lots of different spots. So I have 2n times n minus 1 over n plus 2. And then the denominator is going to end up being 2n squared minus 8n plus 6 over 2n plus 4. And then, since I have a fraction over a fraction, I can actually treat this 2n times n plus 1 over n plus 2. Since I'm kind of dividing by a fraction, I can treat this like I'm multiplying by the reciprocal. I'm going to factor out the 2n plus 4 to 2 times n plus 2. And I'm going to factor 2n squared minus 8n plus 6 to 2 times n minus 3 times n minus 1. And then I'll look at things that can cancel. And those things end up canceling. So I end up with a final answer of 2n times n plus 1 over n minus 3 times n minus 1.